Okay, let's proceed to some integration techniques. So for these transformations of trigonometric functions, we'll try to answer this integral. We have cosine 5x, cosine 3x dx. So how do we solve this? First, we cannot fit this to any of the equations that we already know, or any of the formulas that we already know, because wala tayong formula for cosine of an angle times cosine of another angle dx. But if we try to look at this in this way, change natin to siya as alpha and beta. This alpha and this is beta. So we have cosine alpha, cosine beta, and this seems familiar because we have that identity that has sine, sine, cosine, cosine. Diba? Okay. So if recall, ito siyang ganitong forma, lumalabas siya doon sa identity of sum and difference of cosines, right? So let us recall that cosine alpha plus beta, or the cosine of the sum of two angles, is equal to cosine alpha cosine beta minus sine alpha sine beta. So this is now similar to this. So let us just try to find the equivalent function for this, that in which we could apply our trigonometric formulas for integration. So we also know that the cosine of the difference of alpha and beta is equal to cosine alpha cosine beta plus sine alpha sine beta. Okay? Now, if we want to try to solve for this, we could add these two identities to be able to cancel this out, diba? So if we name this equation 1 and this is equation 2, if we, from these two equations, equation 1 and equation 2, if we subtract na lang equation 1, so meaning equation 1 minus equation 2, no, we add. If we add equation 1 and equation 2, then that will give us, so we just add this, so that would be cosine alpha plus beta plus cosine alpha minus beta. Then if we add this next, then that would become 2 cosine alpha cosine beta, and this would be cancelled out. Okay, so therefore cosine alpha cosine beta, or 2 cosine alpha cosine beta, is equal to cosine alpha plus beta plus cosine alpha minus beta. So therefore cosine alpha cosine beta could be written as 1/2 of cosine alpha plus beta plus cosine alpha minus beta. So from here we could already solve the integral. So this one. So how do we do that? So substitute na natin. So therefore cosine 5x cosine 3x is the same as 1/2 of cosine, that would become 5x plus 3x because our angles are added. So that is 8x plus cosine 5x minus 3x. So that would be 2x. That's it. So therefore, the integral, or if we call this I is now equal to 1/2 times the integral of cosine 8x plus cosine 2x dx. So to answer this, I is equal to 1/2 times the integral of cosine 8x. We know that the integral of cosine is positive sine. So we'll have 1/8 sine 8x plus the integral of cosine is positive. The integral of cosine is still positive sine. Then u is 2x, so therefore we need to multiply that by 1/2. So 1/2 sine 2x plus c. So therefore I is equal to 1/16 sine 8x plus 1/4 sine 2x plus c. That is our answer. So for previous example, we could also derive other formulas for integrals appearing this way. So suppose yung function natin appears to be sine. Let's say sine alpha and sine beta. And also, how about if it's sine alpha, cosine beta, or it could be interchanged like cosine alpha, sine beta. Ganun pa rin naman ang implication. So, we'll have three trigonometric transformations that we need to memorize. So, yung cosine alpha, cosine beta, we already have a transformation for this. So, we'll use this. So, let me rewrite that here. So, it's just equal to 1/2 cosine alpha plus beta plus cosine alpha minus beta. Okay, so that's it. Now, how about for sine alpha, sine beta? So for this, let's use the same formulas or the same equations or identities 1 and 2, but this time let us subtract equation 2 from equation 1. So that would be equation 1 minus equation 2. So if we do that, so that would be this minus this and this minus this. So that would become cosine alpha plus beta minus cosine alpha minus beta, and it's equal to, this will be cancelled out, negative 2 sine alpha sine beta. Okay, so let me just copy this and paste that here. Okay, then if we interchange this, that would become 2 sine alpha sine beta, and it's equal to cosine alpha minus beta minus cosine alpha plus beta. So therefore, sine alpha sine beta is equal to 1/2 of cosine alpha minus beta minus cosine alpha plus beta. So this is our second transformation that we need to memorize. So let me write this here. So that would be 1/2 of cosine alpha minus beta minus cosine alpha plus beta, which is very similar to our first equation, only the sign is different. So pwede naman ito, since plus naman dito, how about interchange lang natin to so that madali lang siyang i-memorize, no? So ito siya at this angle, interchange lang natin yung dalawang function. Okay, para yung difference nila is this lang. So if it's cosine alpha cosine beta, that will be plus. If it's sine alpha sine beta, that will be minus. Then how about sine alpha cosine beta? Okay, so for this, we will be using another set of identities. That would be the sum and difference for sine. Because we know that the sum and difference of two angle for sine is, yung sa mnemonics pa natin, it's sin cos cosine and cos cosine sin. Okay, so again, let us recall the sum of two angles, alpha and beta. That would be sine or sin cos plus cos sin, diba? And if we have sine of alpha, we have sine of the difference of alpha and beta. So sine alpha minus beta, that would be cos, parang ganun pa rin. Sine alpha cosine beta minus cosine alpha sine beta. Okay? Then, ito na siya yung nag-appear. Ito yung i-derive natin, which is this. So, the same method will just subtract the two equations. So, if I name this equation 4, equation 3 and 4 pala. If I name this equation 3, and this is equation 4, so we just need to add equation 3 and equation 4. So if we add that, that would be sine alpha plus beta plus sine alpha minus beta, that is equal to 2 sine alpha cosine beta. So ito ma-cancel out. Okay? So therefore, we have sine alpha cosine beta, that is equal to 1/2 of sine alpha plus beta plus sine alpha minus beta. So this would be our formula. So let us copy this and paste it here. Okay. Okay, for the sake of consistency, pareho lang naman, I mean, inad lang naman sila. So, let's just interchange this para tayong mag-start sa alpha minus beta. Okay? So, ito siya. I'll just interchange. Ganun din naman because the operation is positive, or no, the operation is addition. That's it. So, we just need to memorize these three transformations if this integral appear. Okay? So, it's just 1/2 cosine alpha minus beta plus if it's cos minus if it's sine, and sine yung dito siya addition if it's sin cos. Okay? And if mag-interchange, so that's still the same. The same approach pa rin gagamitin natin. Okay, for your first assignment for this video, you answer this using the transformations that I have just derived. So let's proceed to other types of transformations. So we'll start with we'll call this type 1 transformation, which is for the integral of sine raised to mx times cosine raised to nx dx. So, consider muna natin that m and n, or paano ba? Where either m and n are written where either m or n is a positive odd integer. Okay, so either of these two are positive odd integers. So if we have this type of integral, let's say n is the odd integer, then we can transform the integral by applying this trigonometric identity. We have cosine squared x equal to 1 minus sine squared x. Okay, or that is from trigonometric identities. So meaning, ito yung cosine, this is when cosine is odd. Yung cosine is odd. So yung cosine squared, palitan natin itong identity. Okay, example of this is, suppose we have the integral of sine squared x cosine cube x dx. Okay? So, ito siya yung cosine ang may odd na exponent. So, therefore, ito yung ita-transform natin. So, we could rewrite this as equal to, or how about if I name this as I na lang. Okay. So, therefore, I is equal to sine squared x, and cosine cube could be written as cosine squared x times cosine x dx, right? Then let us transform this or change this to its equivalent identity. So therefore we'll have I is equal to the integral of sine squared x times 1 minus sine squared x times cosine x dx. Now if we distribute, we'll have I is equal to the integral of sine squared x cosine x dx minus the integral of sine raised to 4x cosine x dx. So, we just distributed this like that. Okay. So, next, therefore, ito siya, if we let u be equal to sine x, then du is positive cosine x dx. So, therefore, this is a case of u raised to n du. U raised to n du. Okay. So, therefore, this is simply 1/3 sine cube x. That's a derivative of this. And then minus here the derivative of, again, if u is sine x, du is cosine x dx. So therefore this is just a case of u raised to n du. So the answer there is just 1/5 sine raised to 5x plus c. So this is our answer. Ganun siya kadali. Okay, so if we have, let's call type 2, and that is for the transformation for the integrals of tangent raised to nx dx, or integral of cotangent raised to nx dx, where n is an integer. Okay, so n is an integer. So by this, gamit ulit tayo ng Pythagorean identity. We know that tangent squared x is equal to 1 minus, baliktad pala. Secant squared x minus 1. And of course, cotangent squared x is equal to cosecant squared x minus 1. So, those identities will be useful. Okay, example tayo. Suppose we have the integral, or I is equal to the integral of tangent raised to 4x dx. So we'll try to use this. That would be, we know that tangent squared x, tangent squared x is equal to secant squared x minus 1. So if we rewrite this as the integral of tangent squared x times tangent squared x dx, then we could substitute 1 tangent squared x as secant squared x minus 1 dx. Okay, so therefore I is equal to the tangent of tangent squared x secant squared x minus the integral of tangent squared x. Kalimutan natin yung dx. So let us insert dx here and dx here. Okay, but wait, there's more. Eto, we could integrate this because we know that if u is equal to tangent x du, or the derivative of tangent, is secant squared x. So therefore, this is a case of u raised to n du. Pero in this case, tangent squared x pa rin tayo. But we already solved this in our previous examples. Diba? Gamit ulit tayo ng identity. Okay? So therefore, let me change this first into tangent squared x, secant squared x dx minus the integral of secant squared x minus 1 dx. Okay? So therefore, we'll have I is equal to the integral of this. Again, this is u raised to n du. Will have 1/3 tangent cube x minus, we have an equation for, okay ha? Sige, i-ano muna natin, i-distribute muna natin to, although dali lang naman sana. So, secant squared x dx plus integral of dx. Okay. So, we'll have I is equal to 1/3 tangent cube x minus, we have an equation for this, that is just tangent x, and the integral of dx is just x, then plus c. So this is our answer. Napakadali. Okay, let's proceed to type 3. For type 3, if we have the integral of tangent raised to m x secant raised to n x dx, or if we have cotangent raised to mx cosecant raised to nx dx, where, so yung gagamitin natin dito, or we will consider ito, where n, or the exponent of secant or of cosecant. So where n is a positive even integer. Okay, so suppose we have this. So of course, we'll be using secant squared x, which is equal to 1 plus tangent squared x. So we can use this identity. Or the other identity is sa cosecant squared x, which is equal to 1 plus cotangent squared x. Okay, so let's have an example. Suppose we have the integral of tangent squared x secant raised to 4x dx. Okay, so if we apply these transformations, then we'll have I is equal to the integral of tangent squared x times secant squared x times secant squared x dx, and secant squared x will just change that to 1 plus tangent squared x. So this would be 1 plus tangent squared x dx. Then distribute, we'll have I is equal to the integral of tangent squared x secant squared x dx plus the integral of tangent raised to 4x secant squared x dx. So sobrang dali na because we know that if u is equal to tangent x du is just the derivative of tangent x, which is secant squared x dx. So therefore, this is a case of u raised to n du, same as this, u raised to n du. Hence, I is simply, so atong n, or our n here is 2, so that will be 2 plus 1. So we have 1/3 tangent cube plus, how about here? It's raised, our n is 4, or it's raised to 4. So n plus 1 is 5. So 1/5 tangent raised to 5x plus c would be our answer. So our fourth type will go back to sine raised to mx cosine raised to nx dx. But this time, both m and n are positive even integer. So if we have both as positive even integer, okay, even na siya. Power reduction yung gagamitin natin instead of Pythagorean. So we know by power reduction, if we have sine squared x, that would be equal to 1/2 times 1 minus cosine, double the angle, to x. And if we have cosine squared x, that would be equal to 1/2 times 1 plus cosine of double the angle. We could also use 2 sine x cosine x, which is equal to double sine of the double angle to x. Okay, or pwede natin isulat as sine x cosine x is equal to 1/2 sine 2x. Pwede ganun. Okay, let's try this problem. Let's try to solve this problem. So both the exponents are positive and even. Okay, so let's try first ito. Remember na sa transformations natin, we have sine x cosine x na nag-appear. And this is not the same as the previous transformation because these are the same. So therefore, or these angles are just the same. So therefore, pwede lang tayong gumamit ng double angle identity, which is precisely this. So what we shall do is just i-transform natin to into sine squared theta cosine squared theta. Dito na ko na lang ilagay yung sine squared theta d theta so that this will appear, no? And that is the same as sine theta cosine theta squared. And this one, we could change that, or we could reduce the power of this because this will be double angle na. So ito, pwede din natin i-reduce yung power na magiging double angle, which is ito. This one. Okay. Then this would become 1/2 times 1 minus cosine 2 theta. Okay, then the theta. So for this one, we know that this is this is 1/2 sine 2 theta. Hence, if we square that, that would be 1/4 sine squared 2 theta. Okay, then we'll multiply this with 1/2 minus 1/2 cosine 2 theta d theta. Then let's just distribute. So therefore, we'll have I is equal to 1/8 integral of sine squared 2 theta d theta. So tama na ba? So this, I just multiplied it by this. Then minus 1/8 pa rin times the integral of sine squared 2 theta cosine 2 theta d theta. Okay. So from here, we don't have para sa sine squared, wala tayong formula for that. So, meaning we need to reduce this again. Diba? Power reduction ulit tayo. So, by power reduction, this will become 1/8 times the integral of 1/8 times the integral of 1/2 times 1 minus cosine 4 theta. Then minus 1/8 times the integral of Eto, dali na lang to because this will become u raised to n du because the derivative of sine is cosine. So let me copy that here lang. So that would be sine squared 2 theta cosine 2 theta d theta. Okay. So this, sorry, walang d theta dito. Dapat may d theta pa tayo dito. Yan. So let me just rearrange these two. 1 over 16 times the integral of, so unahin muna natin dito yung distribute. So d theta minus 1 over 16 pa rin. Integral of cosine 4 theta d theta. Then minus 1/8 of sine squared, integral of sine squared 2 theta cosine 2 theta d theta. Okay, so kaya na. So from here we have 1/16 theta minus 1/16 times. Ito siya, if our u here, so this is the case of cosine u du. So if u is equal to 4 theta, du should be 4 d theta. So dapat we need to multiply this by 1/4 kasi dapat 4 d theta dito. Okay, so that would be 1/4 times the derivative of cosine, which is the integral of cosine, which is positive sine. So sine 4 theta. Okay, and then minus, ganun din dito, we have 1/8 times, remember that if u is 2 theta, so therefore du is 2 d theta. So dapat meron tayong 2 pa dito, then we multiply this again by 1/2. So we'll have 1/2 times, since this is a case of u raised to n du, that would be u raised to n plus 1 over n plus 1. Okay, plus c. So therefore I is equal to 1 over 16 theta minus 64. 1 over 64 sine 4 theta minus 1 over 48 sine cube 2 theta plus c would be our answer. As your assignment, you solve these integrals using the transformations that we have discussed. And that's it for our lesson.